Today we're talking about congruent triangles using angle, angle, side as the postulate to prove congruency. So, how do I prove triangle congruence using angle, angle, side postulate? Now recall that postulate is a fancy math word for rule. And to prove that two triangles are congruent, I need to show that a specific ordered combination of corresponding parts are congruent. So they have to be in a specific order, and it has to be a specific set. So triangle congruence using AAS. AAS stands for angle, angle, side. So if I can prove that, then I can prove that triangles are congruent. So if I can prove that two angles and the non-included side, that means not between, of one triangle are congruent to the corresponding parts of the second triangle, then I can prove that the two triangles are congruent. So as demonstrated in the picture, I have to prove that angle A is congruent to angle D. Angle C is congruent to angle F. And then I have to be able to prove that BC is congruent to EF. Oops. Then I can state that triangle ABC is congruent to triangle DEF. Notice that the side that we're talking about is not between the two angles. So angle, angle, side would be like this: angle, angle, side. And then have the same angles here. But it wouldn't be angle, angle, side, with the side in between. So it's not, the difference is where this side is located. Recall that there are no triangle shortcuts for side, side, angle, or angle, angle, angle. So looking at number 1, we're going to decide if the triangles are congruent using angle. This is supposed to be angle, angle, side. So when you look at number 1, it doesn't appear to be congruent by anything, because while it says that these sides are congruent, it doesn't compare them to the other triangle. So I can't say that these are congruent. Not with the information that's been given to me. When we look at the number 2, I have corresponding angles. I just need to know that that side is. Actually, I know that side is because it's reflexive, so I can say that this is congruent by, I don't know what I just did, by angle, angle, side. Because I can say that that shared side is congruent. When we look at number 3, I know that these are vertical angles, so I know they're congruent. So then I have angle, angle, side, angle, angle, side, and angle, angle, side. So I can say that this is congruent by angle, angle, side. Number 4 has no such, I don't have vertical angles, even though those are close to related, they're not vertical, so I don't know what they are. So I don't have any way to say that this is congruent given the information given to me. When we look at number 5, again, we're looking to prove what's needed to prove that. So the first one that's easy is angle V. So I need to know that angle UVW is congruent to angle AVC. They're vertical angles, but I have to state that in my problem. The next step would be, remember I need it to not be included, so I have to use this angle. I need to be able to say that angle U is congruent to angle A. I can state, or at least prove, that angle FTD is congruent to angle UTS. And then I want to use the side that's not included, so I want to use this one. I need to be able to prove that FT is congruent to UT. For number 7, even though this is a common side, I have to be able to prove it, so I need to be able to state that FE is congruent to EF. And then I want to use the far angles, because they're the ones that would not make the side included, so I need to be able to prove that angle G is congruent to angle F. Number 8 already has the angles identified, so I just need to pick the side that's not included between the two angles. So I need to prove that NM is congruent to XY. And that's how we prove triangles congruent, using angle, angle, side.